So what do we conclude here? How much?
0.
Okay, so we plugged in -2, right? So this is -2 plus 1 divided by 3 multiplied by -2 plus 6. Is this correct? Okay. Is the numerator -1?
Yes.
And the denominator is 3 times -2, which is, and -6 plus 6 is? Good. So what do we know about any number, not 0? 0 over 0 is a totally different situation, and you have to wait till calculus. So a number over 0, not 0 over 0. Nope. So, okay, let's talk about this. This is very important. So assuming I have not a good example. Assuming I have $0 in my pocket, and I choose 1, 2, 3, 4, 5, 6, 7, 8. 8 of you to share my 0 with. How much will you get from my 0? You're going to get 0, right? If I divide it by any number but 0. But now let's talk about the other way around. These two cannot be the same. I hope you agree. 0 over 8 or 8 over 0 cannot be the same. True? Okay, so let's say we don't know what it is. I have no idea what 8 over 0 is, and I'm going to say it's an unknown number. I'm going to call it x. Are you with me? I don't know. I want to see what x is. So now I'm going to do this. Is 5 the same thing with 5 over 1? Is 10 the same thing with 10 over 1? Well, then in that case, you will agree that x can be rewritten as x over 1. Acceptable? So then I will rewrite this equation as 8 over 0 equals x over 1. Would you agree? X or x over 1 must be the same. Well, this happens to be a proportion. So in a proportion, a over b equals c over d. Only in a proportion I'm allowed to what am I allowed to do? Only in a proportion. Not only in a proportion. Only in a proportion.
That's what I was thinking, but I wasn't sure. Cross multiply.
Only in a proportion. If it's not a proportion, I can never cross multiply. So then if it's a proportion, meaning one fraction line, one equal symbol, of course, and one fraction on the other. If I have this is not a proportion. But if I have a proportion, then AD equals BC. Mandatory. Let me give you an example of a proportion, a numerical proportion. 1/2 equals 10 divided by 20. Do you agree that 1/2, how did I get 10 over 20? I multiply top and bottom by 10. Is 1/2 the same thing with 10 over 20? Yes? So then this is 1 times 20, which is 20. And this is 2 times 10, which is 20. That's mandatory. So that's why a proportion A over B equals C over D must be translated into this. A times D equals B times C. In this proportion, I would like you to cross multiply and tell me what to write. How much is 8 times 1?
8.
How much is 0 times x?
0.
0. So I'm telling you that 8 equals 0. Which means, of course it's false, which means this does not exist. It does not exist. However, we don't like to say that. We like to say it's undefined. So we have to write here, undefined. So I'm going to write a note. Division by 0 is, thank you, undefined. Division by 0 is undefined. And it makes sense, right? 0 over 8 cannot be the same with 8 over 0. And it happens that this does not exist, period. Okay. So now I'm going to ask you, after I explain, two more concepts. The concept of domain and the concept of range. Both are very important, however, the domain is super important. Okay, the domain represents the values that the independent variable, I'm going to in short say that x can take. The numbers that I can assign to x in a function create all those numbers create the domain. What do you think the range will be? Exactly. So the values that the dependent variable, whatever it is, v of p, p of t, whatever f, that y can take. So now I would like to look at a couple of functions. And I would like to name them so we start knowing their names. I don't want you to think that they're all the same, so I'm going to say this is f1, this is f2, this is f3. Or you can use any other notation you prefer. So 2x plus 1, the absolute value of x minus 3. And I want to come back to that function x plus 1 over 3x plus x. So these are three different functions. I hope you agree. They don't look alike at all. Okay, what type of function do you think is the first one? Actually, that's probably the only one we know from the previous experience in with math. Yes, it's a linear function. Yes. You're right, linear. It's another way of saying it, but this is a linear function. Good. What do you think the second one is called? We have not seen it before, but what do you think it's called?
Absolute function.
The absolute value function, of course. Makes sense. Of course. What do you think the third one is? Since it has a ratio in it, what can it be? Rational. But it has to have x in the denominator. This is not a rational function. This is linear. This is 0.5 times x. It does not have x in the denominator. So this is linear. This is rational. It has a ratio, and the denominator has x somewhere. Good. Now coming back to f1, I would like you to tell me when we are asked to determine the domain, we are not really asked to perform an operation unless an operation is necessary to find the domain. So for example, for this function, if you ask me what is the domain, I will just not write anything and look at it and say, can I plug in x anything I want? Can I plug in -5? Yes. 0? Yes. 10? Will I always be able to give an output? Yes. When x is 0, I give the output 1. When x is 1, I give the output 3. When x is -5, -9. When x is 10, 21. Right? So I can always give an output for any x or for any input. So then what would be the domain of f1? -infinity to infinity. Anything. I call these functions friendly. No headache. Don't have to do anything. Okay, now let's look at the second one, absolute value. Again, this is a second type of function, but the same concept. I don't have to do anything. Can I plug in x anything? Yes. Can I subtract 3 from whatever? Yes. Can I apply the absolute value to that whatever? Yes. So what do I conclude about the domain of F2? Same. However, the third one requires some work. In the third one, I'll say, what can happen here? The top can be anything. The top of a fraction will never give me any worries. Oops, but I see a 3x plus 6, which could be 0. I cannot have that, because I just learned that division by 0 is undefined. So on the side, I will write 3x plus 6 cannot be 0. I will move 6 to the other side. 3x cannot be negative 6. And dividing both sides by 3, I will say, wait a minute. This function is not a friendly one. It takes any x except 1. Which x it cannot take? Exactly. And we saw that 2 pages ago. When I plug in -2, I cannot give you an output. If you say plug in -2, and I'll say, I can't. If you say plug in 0, then I'll give you an answer. I'll give you 1/6. If you say plug in 1, okay, no problem, I'll give you 2/9. If you even force me to plug in 3a, I will give you 3a plus 1 over 9a plus 6. No worries there. But if you say plug in -2, I'll say, nope, nice try. I cannot give you a number. So based on this condition, I would have to write the domain. How do I write in mathematical terms everything except -2? Now you have to think of what we started with. Is it a union or is it the intersection? See, I could have never done this with a board. Exactly, because this side is not intersected with this side. I have to remove -2. So how do I write the domain for F3? It has a hole, -2.
That's what I was thinking.
Union what? Remember, the symbol means -2 is not there. Union what? Exactly. So one more time, when I'm asked to find the domain, in many situations, I don't touch the paper. I don't do anything. I just look. But in this case, here I had to state a restriction. This is a restriction. 3x plus 6 cannot be 0. Why? Division by 0 is undefined. So therefore, this quantity, it better never be 0. Because if it is 0, then I cannot have an output. Function is not defined there. So I took the denominator, I set it not equal to 0. I solved and I got that, -2 won't work. Everything else will, but not -2. Okay, any questions here? Any questions? Okay, I would like to look at a graph and beat it to the head as much as we can. Very important questions. This is very important to be able to read from a graph. Just going to make one up. This is my graph. This is my function f of x. Oh, by the way, is it a function? By the right? And I'm going to put some numbers. I'm going to put 1 here. I'm going to put 1 here. I'm just going to say -3 here. One, 2, 3, 4, 5, 6. Good. Okay. Now I would like you to tell me what is the domain of this function. First question, domain. Right, because the function goes on forever. Very good. 2, I want you to give me the range. So the domain is on the x-axis from the leftmost point to the rightmost point. The range is on the y-axis from the lowest y value to the highest or the largest y value. Thank you. Now I would like us to answer many other questions, like X-intercepts, comma, if they exist. They or if it exists. What do I mean by X-intercepts? They're also called the zeros of the function. Important to know that. We will less talk about zeros and more about X-intercepts in this class, but in the next classes, we do talk a lot about zeros of a function. Same thing, the X-intercepts. Does this function have X-intercepts?
Yes.
Can you read them in the form of an ordered pair? One comma 0 and 5 comma 0. Number 4, Y-intercept. So remember the equation of this line is altitude 0, y equals 0. The equation of the x-axis is y equals 0. Okay, so then the Y-intercept. Yes, here it is, 0 comma 1. Now I'm going to ask you number 5. Find f of 3. What is given in this problem? And by the way, let me refresh your memory. This line is the y-axis. It's a position, not an altitude, position. So this is x equals 0. The equation of the y-axis gives a position, x equals 0. The equation of the y-axis gives the altitude, which is y equals 0. Okay, f of 3, please. What is given in this question? I'm asked to find f of 3. What is given to me? The x is given. Excellent. So x equals 3. How do I graph? This is not a point. How do I graph x equals 3? And what is it? It's a vertical line at 3. X equals 3 is a vertical line at 3. You can imagine that you draw it or actually draw it. This is x equals 3. Does it cross the graph of the function in any particular point? And from this point, I will read the y coordinate. What is the y coordinate? Very good. So then f of 3 equals, according to the graph, is what? Good, exactly. 3 comma negative 3. Perfect. Any questions? We understand this mechanism. Yes? Thomas, are you okay?
Yes.
Okay, 6. Find x such that f of x is 1. Find x such that f of x is 1. What is given now? Y is given. So I am given y equals 1. This is not a point, but what? A horizontal line, y equals 1. You can imagine you draw it or actually draw it. Have to draw it so I can explain what I'm doing. Indeed, it's the altitude, y equals 1. Does this line cross the graph of the function anywhere?
Yes.
So then I read two different x values. When y is 1, I read x equals 0 and x equals 6. X equals 0 and x equals 6. What are the ordered pairs that we just determined for this function? 0, 1, and
Oh, 6, 1.
very good. We read from 0, 1 and from 6, 1. Very good. Now, a graph can be given like this. If a graph is given like this, you're not allowed to connect the points. This is the graph. I'm going to ask you a couple of questions. One, is this graph, does this graph represent a function? Is this a function? Second, if it is or it's not, there is always a domain. So I want the domain. And question 3, I want the range. So first question is this a function? Is this a function? No. By the vertical line test, if I draw a vertical line through the vertical line here, it hits 2 points, so it cannot be a function. Not a function. A relation by the vertical line test. Perfect. So I'm going to put some numbers now in here. 1, 2, 3, 4. 1, 2, 3. So even if it's a relation, it has a domain and range. Can anyone dictate a domain? Exactly. Since we cannot connect, remember the set notation from the beginning of the class today? This is how I have to write it. If I write it with parentheses or brackets, it means that everything in between is included, and it's not. That would be false. Can anyone read the range now? One, 2, and 3. And nothing else. I cannot use parentheses or brackets because nothing else is there. This completes 3.6. So coming back here, I'm kindly asking you, this is again, as you see, a review, but I've done it everything. These are review. Even the next one is a review, and the next one is a review as well. So this is completed. So please do not forget. So let's see what we can accomplish now from 2.5. And that is formulas and problem solving, 2.5. First thing that I would like to present to you are some models. Not beauty, but models from physics and chemistry and geometry and so on and so forth. For example, here's one. Anyone remembers A equals X times Y? It's the area of a rectangle. How many variables we see here? How many unknowns we see here? I see 3. I see A, which I don't know what it is, right? I see X, which again I don't know, have no idea, and I see Y. So this is a formula from geometry. What if I'm asked to solve for y? Solve for y. What will I do? I cannot plug in a number for a or a number for x. No, I have to keep them as the equation is given to us. A equals x times y. I have to have a and I have to have x. But I'm asked to solve for y. What should I do to both sides to solve for y? That's it. I'm done. So I solved this formula that comes, or model that comes from geometry for a particular variable that was indicated to us. Okay. Let's say another formula from economics. A equals P plus PRT. Let's say we are asked to solve for R. What will be the first step towards solving for R? Of course, I have to get this out of the way because it's a term that does not contain the variable and it has to go to the other side where I have terms with no variable. So this is A minus P equals PRT. I'm still solving for R. What will I do next? Both sides by? Very good. Be very careful. We already talked about terms and factors. Be careful how you write it. You can write it's divided by, oops, I meant PT, of course. I'm not dividing by the variable I'm solving for, right? So, and PT, and I'll simplify factors. And I get R to be A minus P divided by PT. This will be a terrible mistake to attempt to simplify this P with this P. Why? P here is a term or a factor?
It's a fact.
Factor. P here is a term or a factor? A term. I cannot simplify a term with a factor. However, there is another option here. I accept both. Most of the time, I prefer the second option, which I'm going to show you now, in which I divide term by term and simplify each term or each fraction, like this. So I have A minus P equals PRT. I know I'm dividing by P and T. I can write A divided by PT minus P divided by PT equals R. In this case, I am allowed to simplify factors. P is a factor at the top. I can simplify and I get 1. I have to write 1 because if I don't write 1, I may think it's 0. And P divided by P and I get 1. So the second option, this is perfect, but don't simplify. And the second option would be A over PT minus 1 over T. Both are acceptable. In the second option, I divided each term by PT, and I simplified it individually. Okay, let's look at a word problem. Let's say 38 on page 123. Since this class is a hybrid class, I have to move on because we only meet once a week. Okay, so please keep that in mind. If the length of a rectangular parking lot is 10 meters less than twice its width. So a rectangular parking lot will look something like this. Okay. So we know that its length is 10 meters less than twice its width. Before we analyze this, I'm going to say the following. Assuming you have $100 in your pocket, I come in today and I say, I have $10 less than what you have. What calculation will go through your mind? 100 minus 10 or 10 minus 100? Think for a moment. One more time. You have $100 in your pocket, and I come in and I say, I have $10 less than what you have. What will go through your mind? 100 minus 10 or 10 minus 100?
100 minus 10.
Of course, be very careful. It's less first, right? It's confusing a little bit. I'm saying I have $10 less than what you have. And you have to think about it a little bit reversed, right? 100 minus 10. Now, careful. If the length of a rectangular parking lot is 10 meters less than twice its width, so I have to use some names. I'm going to say, I don't know, it doesn't matter. This is X and this is Y. So this is the length and this is the width. So the length is 10 meters less than twice the width. The length is 10 meters less than twice the width. Please tell me what to write in mathematical terms, of course. The length is equals, the length is 10 meters less than twice the width.
QW minus 10.
Yes, 2y minus 10, very good. 10 meters less than twice the width.
Wouldn't it be like a volume, like you could just say that's
It says is. Done. If it says is, I'm done. It says is. It does not say the length is less than blah, 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 by blah, blah, blah. I see the confusion. I see the confusion. No. It says the length is 10 meters less than twice the width. Better? Okay. How many variables we have in this problem? Length and width. How many equations I need? Okay, let's read on. The perimeter is 400 meters. What is the formula for the perimeter of a rectangular figure?
X plus 2y.
Very good. So what is the second equation? The perimeter is 400 meters. I need the second equation right here. What do I write? Yes?
y
2x plus 2y. That's it. No question, right? Clear? So there are a lot of keywords in math. But coming out of this class, if you remember two from me, I will be extremely happy. The keyword number one is simplify. It's a very important keyword. It should be in the back of your mind every time you even read or write a problem. Simplify, simplify, simplify. The second keyword in this class is factor. Factor, factor, factor. As much as you can. Factor everything. Of course, not everything, but these are the two keywords every time you open the book or think about math. Simplify, 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 factor, factor, factor. Okay, so I'm looking at these two equations, and I know that one of the two equations can be simplified. Which one and by what? Keywords.
The second one,
Of course.
minus 2 by 2.
Exactly. So I'll divide both sides by 2. I get x plus y equals 200. When I divide everything. And I divide it term by term. 2x divided by 2, 2y divided by 2, 400 divided by 2. Now, what is this called? We're going to talk about it in this before test 1. This is all chapter 4. And you can say, are we doing chapter 4 now? No. But it's very good to anticipate. This is called a system of 2 linear equations in 2 variables. 2 equations, 2 variables. A system. A system means 2 equations put together. Have to be fulfilled at the same time. The same with compound. Compound, 2 inequalities put together. Somehow related in a way. Okay, so a system of 2 linear equations in 2 variables. What do you think I'm going to do? Look at these 2 equations and say, oh yeah, you can... What? I don't know how to solve an equation with 2 variables. I don't know how to solve an equation with 2 variables. But I can substitute. What will I substitute and where?
Substitute the x.
Exactly. When I say x or 2y minus 10, I mean the same thing. So this x can be replaced by 2y minus 10. Because x equals 2y minus 10. Everywhere I see x, I can plug in 2y minus 10. Can anyone dictate the new equation that will have only one variable that we can solve?
2.
Yes, 2y.
Yeah, it's 2 because you have a 2 already there.
So, not yet. Yes, but it's 2y. I have to replace x.
Never mind, because I'm a step ahead.
Okay,
Yeah.
so 2y minus 10 plus y equals 200. So we replaced x in the second equation by 2y minus 10. Why? Because the first equation told us x, if I say to you x or I say 2y minus 10, I mean the same thing. They can be interchanged. So now this equation I know how to solve. This is 3y. I'm moving 10 to the other side, I get 210. And I know that y must be 70 meters. Is that good enough? No. I have to go back, determine x, and make sure that both equations are fulfilled. So if I have y to be 70, how much is 2 times 70? 140 minus 10. So then x equals 130 meters. What is the ordered pair that appears, I haven't checked yet, that appears to be the solution of the system? Careful how you put them. Very good. Now, I have no idea whether this is correct, and I don't need you to tell me, and you don't need me to tell you. So what will you do to check the solution? Plug it in, exactly. Right here, back in the original problem. So x is 130 and 70, 130 and 70. And I have to check both, and they have to, the solution must work in both. Otherwise, it's not the solution. So 2 times 70 is 140 minus 10 is 130. Check. 2 times 130 is 260, and this is 140. How much is 260 plus 140? 400. And now I know that this is yes. I checked. You don't need me, and I don't need you, right? I go back and check, and I don't have to wait for you to say, hey, is it true? Is it correct? No, I go back and check. So the length of the rectangular parking lot is 130 meters, and the width is 70. And both conditions are fulfilled. Any questions for me? Any questions for me? Okay. So please work on these problems, all these. Equations of lines, I still have 7 minutes. I would like to review this. I will not ask you necessarily to work on these problems if you don't want to, but I still have time to present those equations. We may not be able to do enough word problems because I need about 2 problems with you. So next section is 3.5 equations of lines. So at least let's list those. Okay. So first of all, given 2 points. Let's say I'm given x1, y1, and x2, y2. So given 2 points. Can anyone tell us the slope? How to find the slope of a line passing through those points? No, just the slope first. But you're right. Yes, the point, and then that will be my next question, the point slope form. So how do I write the slope?
y2 minus y1 over x2 minus.
Very good. That's the definition of the slope. Now, the slope Y-intercept form. So that's number 1, and that's number 2. Slope Y-intercept form. Y equals? Very good. Where M we know is the slope. B is an ordered pair. It comes from an ordered pair 0, comma B. This is the Y-intercept. Very good. The third one, it you just mentioned, the point slope form.
Y minus y1 equals n. X minus x1.
Very good. Point slope. So if I'm given the slope, where I have the slope somehow determined, and I have at least 1 point, then I can determine the equation of the line. If I'm given a point that is 0, comma blah, I should not use this. I should use this because it's easier. But if I'm given a point 1, comma 3, I cannot use this. I will use this. Okay? Parallel and perpendicular lines. Maybe I should just present the type of lines first and then, okay. So we can have 4 different types of lines. That's it. Nothing else is possible. Can anyone give us the slope of this line? How much? Of course. Can anyone give us the slope of this line? And what type of line is it? Of course. What about this one? Vertical. What is the slope of this line? It cannot be 0. This is already taken. It's the other one, right? The 8 over 0 and the 0 over 8. If this is 0 over 8, this must be the opposite. The other one. What was the other one that we talked about? Exactly. Undefined. What type of slope is this? Not the number, but what type? Very good. That is a positive slope. It looks like this. A line that looks like this has a positive slope. Okay, what about this one, last one? Negative. Okay, I know I have 3 minutes left. So now let's talk about parallel and perpendicular, and then we'll take it from there next time. Parallel. Parallel lines. Okay, these 2 lines are parallel. This one has slope m1 and this one has slope m2. What can you tell me about the slopes of these 2 lines if they are parallel?
We'll never accept.
True, but I want to talk about their slopes. Is there any relationship between these 2? Oh, but I can have this. So what is the relationship between M1 and M2 for parallel lines?
They'll be the exact same.
Exactly. If two lines are parallel, they must have the same slope. Otherwise, they will intersect. Exactly what you said. They will never intersect. Why? Because they have the same slope. So, for example, this line and that line, they must have the same slope, 0. That's why they will never intersect. Okay, perpendicular lines. So let's say this is a line, and this is the other line. It's perpendicular to the brown one because there are 4 90-degree angles here. So this is, let's say, M2. This line, the orange line, has M2, and the brown line has M1. What is the relationship between these two lines now? They cannot be the same, right? Because they would be parallel. They are perpendicular. So what is the relationship between M1 and M2 when lines are perpendicular? True, but the relationship between the two slopes?
Slopes are the exact opposite.
Negative reciprocals. So M1 will equal the opposite of the reciprocal of M2. If you cross multiply, because this is a proportion, if you put it over 1, I prefer to remember it, M1 times M2 equals -1. They are the same. If you cross multiply, you get this. So if this line has slope 3, what will be the slope of this line? -1/3. If this line has slope 2/3, what will be the slope of this one? -3/2. Very good. Thank you for coming.